Hey guys, I am here to talk to you about application problems involving systems of equations. So thanks for watching. We're just going to go through two practice problems together. And so just as a quick reminder, here's your steps to solving systems of equations, word problems. Like we always do, you're going to identify the two variables. So you're going to write down like x equals the number of, fish, and then like y is equal to the total price or whatever, okay? And then using those two variables that you've identified, you're going to write down two equations now. So instead of one equation, we're going to write down two, and that's why we're going to use systems of equations. And just as a quick reminder, and you might want to jot this down in your notes, if you have one independent and one dependent variable, you're going to use y equals mx plus b to write your equation. But on the other hand, if you have two independent variables, in other words, like two variables that don't affect each other, then you're going to use ax plus by equals c to write your two equations, okay? So that's just a quick reminder. So after you have your system of equations written, you're just going to solve the system, and you can use either elimination or you can use substitution, whichever one you prefer. And you're going to solve for x, you're going to solve for y. You're going to write your answer as a point, x comma y, like we always do. And then finally, the last step, you're going to interpret your solution in the context of the problem, meaning like you're going to write a sentence. All right, ready? So this is going to be number 3 in your packet. Let's read it real fast, and then we're going to go through that process. So a test has 20 questions worth 100 points. The test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. How many true-false and multiple choice questions are on the test? So step 1, like we said, you got to define your variables. And remember, your variables, a lot of times, like the actual question is really going to tell you what the variables are going to be. It's how many true, false, and how many multiple choice questions that are on the test. Or in other words, like number of true, false questions, number of multiple choice questions on the test. So those are the two variables. Those are the two things that we don't know, that could change, that we're looking for. Remember, that's how we kind of like identify a variable. And then you think, all right, do we have two independent variables or do we have one independent and one dependent? So in this case, one doesn't necessarily affect the other. So we have two independent variables. So remember, it doesn't matter which one you call x and which one you call y. I wrote this one down first, so I'm going to call that one x and that y, okay? So now I have my two variables. If they're both independent, remember, I'm going to use ax plus by equals c. And remember, we talked about c being like the total. So you're going to look for the total or the totals in the problem. So if I look, I see that I have two totals. The test has 20 questions total, right? And it's worth 100 points total. So my two equations are going to be equals 20 and equals 100. All right, so if I go back and skim through the other kind of like numerical values that they give me, they tell me that the true-false questions are 3 points each, and the multiple choice questions are 11 points each, right? So this is all about like points. It's the number of points, right? So those two values are going to go in the equation that's about the points. They're going to go with the 100. So X was true, false question. So each one of those is worth 3 points. So it's going to be 3X. And multiple choice are going to be worth 11 points each. So 11Y, right? And then the 20, that's the total number of questions. Well, if X is the number of questions that are true, false, Y is the number of questions that are multiple choice, I can just add X plus Y together, and that's going to get me the total number of questions, which is 20. All right? So those are my two equations. Those are my system of equations. That is, I think, the hardest part. The rest of this, hopefully, you should be able to breeze through. So we need to solve the system. We are going to solve, well, I should say you can use either substitution if you want to get one of the variables by itself, or I'm going to use elimination because I think that's a little bit easier. These are set up for elimination for me. So I'm just going to take this top equation, multiply by -3, because I'm going to get the x's to cancel. So this is -3x minus 3y equals -3 times 20, -60, right? And so now I multiplied through that equation, so I'm kind of like done with that equation. I don't need it. And now I'm going to add my two equations together. So 3x minus 3x cancels out. 11y minus 3y is 8y. And 100 minus 60 is 40. And then I'm going to solve for y by dividing by 8. And y is equal to 5. So I have y, I now need x. So I'm going to take this y value and I can plug it back into either of the original equations, like here or here. This x plus y equals 20 that I crossed out. I know it's hard to see now, but that's going to be a lot easier. So x plus, now instead of y, I'm plugging in a 5 is equal to 20. And now I have to solve that equation for x. So all I have to do is subtract 5 from both sides, and I get x is equal to 15. So now I have my solution in terms of a point. It's the point 5 comma 15. But I really need to answer the question. The question said how many true false questions and how many multiple choice questions are on the test. So remember, x is the number of true false questions. X was 15. So there are 15 true false and 5 multiple choice questions on the test. So there we go. We answered my question. Make sense? All right, so that's an example of a word problem using standard form. And again, I use standard form because I had two independent variables, and when my equations are in standard form, a lot of times it's easier to solve using elimination. Now I want you to flip to number 8. So number 8, let's take a look. Two different electrical businesses charge different rates. Business A charges $30 for a service call plus an additional $45 per hour for labor. And then business B charges $45 for a service call plus an additional $40 per hour for labor. So when would it cost the same to use both businesses? So we're always going to start with defining our variables. Remember, variables are something that could change, something we don't know, something that we're looking for. What is the question asking you about? It's asking you for when, that's like time, right? Would it cost the same? So cost and when. And if I go back and kind of like read the information, the two things that I don't know are how long is it going to take and how much total is it going to cost. So my two variables are number of hours. and the total cost. So think about, do we have one independent and one dependent, or two independent variables? So in this case, the number of hours is going to affect the total cost. So that means the number of hours is independent, total cost is dependent. So if I have one independent and one dependent variable, I'm going to use y equals mx plus b to write my two equations. As a quick refresher, y equals mx plus b. M is the slope, b is the y-intercept. And we said in the context of like a word problem, the slope is always like the rate of change. And we know something's a rate of change because it's going to use that keyword like per, each, every, like 45 miles per hour, something like that. And then B is always your starting value. What do you start off with? Okay. So now that we know that was our little refresher. If I look back into the problem, I give you information about business A. So business A charges $30 for a service call plus $45 per hour for labor. So all of this information kind of like goes together. Let me just circle it real fast. And then I have information separately about business B. So each of that like different information is going to give me one equation. So let's think about my equation for business A. They charge $30 for a service call plus an additional $45 per hour for labor. So $45 per hour, that's your rate of change. That's your slope. And then, oh my goodness. So this is your slope. And then $30 for a service call, that's how much they charge just to come out. So that's your starting point. So your first equation is going to be y is equal to 45x plus 30. And now let's look at business B. So business B charges $45 for a service call plus an additional $40 per hour. So again, $40 per hour, that's like your slope rate of change. And they charge $45 for the service call just to come out. That's your y-intercept. So it's going to be y is equal to 40x plus 45. So now that I have my two equations, I have to think about which method am I going to use to solve this system, elimination or substitution. So in order to use elimination, my equations have to be in standard form. AX plus BY equals C. These are not in that form. So I could put them in standard form, or I could recognize, well, I can use substitution when a variable is by itself. So I really have both y's by itself. So I'm going to use substitution. I'll start with the top equation. This y is equal to this. So I'm going to plug that 45x plus 30 in for the other y. So for the other y, it's going to be 45x plus 30. And that's the only thing really I have on that left side of the equal sign. And then equals 40x plus 45. So now I substitute it in. Now I have to solve. So if I look, these parentheses, that's the only thing, on the left-hand side of the equation. I only have that parentheses, so I don't really have to do anything. I can just drop them. So I have 45x plus 30 equals 40x plus 45. I don't have to like distribute in or do anything crazy. Now just solve for x. So if we want to get x by itself, we're going to get the plain old numbers, the constants together. And then we want to get the x's together. They're on different sides of the equation. So I'm going to subtract 40x from both sides. And I have 5x is equal to 15. I divide both sides by 5. I get x equals 3. So now I have x. I need to solve for y by plugging in. I can plug into the top or the bottom equation. Doesn't matter which one. I'll just plug into the top. So y is equal to 45. And then x is 3 plus 30. So to solve, I got to multiply 45 times 3. And then I'm going to add 30 to it. So my point is the 0.3 comma 165, right? But then remember, we got to answer the question. So we have to put this kind of like in the context of the problem. When is it going to cost the same to use both businesses? Well, think about your variables. X is the number of hours, Y is the total cost. So if they both take 3 hours, it's going to cost them both $165. So after 3 hours, it would cost both $165. And that is it. So again, just to reiterate, this problem, when we defined our variables, we had one independent and one dependent. So because we had one independent, one dependent, we had to use y equals mx plus b to write our equations. And then when we have y equals mx plus b to write our equations, a lot of times it's going to be easier to use substitution to solve the system. But you could use elimination if you wanted to move things around and do that. That's fine too. All right. That's it, guys. Thank you so much for watching. Have a great day.